So today's presentation is about how to solve a system of equations using algebra. The plan for today's lesson will be to first give you a definition of a system of equations. We will go through the methods used to solve a system of equations using algebra, and then I will give you an example of how to actually implement one of those methods to solve a system of equations. But before I go through the lesson, I just would like to give you first a scenario that you can think about as we go through the lesson, because I believe that for each concept we learn, there is always an application for it in the real life. So imagine you went to the grocery store to buy some fruits, and you bought 5 pieces of mangoes and 5 oranges. You went to the cashier to pay for your purchase, and you found that the person in front of you actually had a big family, and he bought the exact same type of mangoes and oranges, but he got 10 mangoes and 8 oranges, and for his purchase he paid about $20 for the price of mangoes and oranges, and for your purchase you paid about $11. So can you actually use this information to come up with the price of each piece of mango and each orange? This is something that we will learn as we go through this lesson. So what is the definition of a system of equations? So at the top of the screen there, you see equation 1, 4x plus 2y is equal to 22, and equation 2, 14x minus 8y is equal to negative 28. So here you see two equations in two variables, x and y. So this is a system of equations. You could have 3 equations and 3 variables. For example, equation 1, 2, and 3 in variables x, y, and z. You could actually have 4 equations or 4 unknowns, and so on and so forth. And the exercise here is to try to determine the x and y values in these equations. We can use algebra to do that, and to obtain the values of x and y, what you could do is you could use the method of addition, you could use something called method of subtraction, you could use other methods that can be found in algebra, like the method of substitution, or you can solve it graphically if you would like. In today's lesson, we'll only use the method of addition to solve or to determine the x and y values. And in order to do that, again, we have the equations 4x plus 2y is equal to 22, 14x minus 8y is equal to minus 28. So the idea of the method of addition is to add those two equations, and in doing so, you will be eliminating one variable and solve for the other value. So how can we do that? So if you look closely in this equation, you will see that the term y has a positive sign in equation 1 and a negative sign in equation 2. If somehow we can make the plus 2y plus 8y and we add it to a minus 8y, we can actually eliminate the variable y. Alternatively, if we can make the minus 8y to become a minus 2y, and then add it to the plus 2y, you can end up with 0. So now you solve for the only one variable left in those two equations, which is x. So how can we do that? You can actually do it in different ways, as I explained. The first one is to try to make the plus 2y becomes a plus 8y, and in order to do that, you just multiply it by 4. So 4 times plus 2y becomes plus 8y. If you add it to minus 8y, you end up with 0. The only problem here is you can't just multiply 2y by 4. You have to multiply the whole equation 1 by 4. So this is the process that we will do now. What we will do now is to multiply the first equation by 4, the whole equation. So 4x plus 4 times 4 becomes 16x, plus 2y times 4 becomes plus 8y, and that's equal to 22 times 4, which is 88. We'll leave equation 2 the same. 14x minus 8y is equal to minus 28. And now the parameter y becomes plus 8y minus 8y, and it just vanishes when you add them together. So if we use the method of addition, the idea is to add both of the equations. And now when you add both of the equations, what you're going to get is 16x plus 14x is equal to 30x, plus 8y minus 8y is equal to 0. And that's equal to 88 minus 28, which is 60. So now how I solve for the parameter x? What you do is you just divide by 30 in both the left-hand side and the right-hand side. So if you divide by 30, so 30 divided by 30 is equal to 1x, and 60 divided by 30 is equal to 2. and in this case x will be equal to 2. So we use the method of addition to add those two equations to and come up with the variable x. So how can we get the value of the variable y? So to obtain y, what you could do is you solve either equation 1 or equation 2 using x is equal to 2. Okay, so how can we do that? In this example, I'm going to use equation 1. So equation 1 states that 4x plus 2y is equal to 22. And we know now x is equal to 2. So if I substitute with x is equal to 2 in that equation, so 4 times 2 plus 2y is equal to 2. So this equation is only a function of y. Can you solve for y? It's easy to solve for y now, but because what we could do is we can have the term y on one of the left-hand side, for example, and move all the other numbers to the right-hand side. And when you do that, you end up with 2y on the left-hand side. It's equal to 22 minus 4 times 2, which is 8. But when you move it from the left-hand side to the right-hand side, it takes a negative sign. So 22 minus 8 is equal to 14. So 2y now is equal to 14. Can you solve for y? That's easy now, because what you do is you divide by 2. So if you divide the left-hand side and the right-hand side by 2, so 2 divided by 2 times y is equal to 1y. 14 divided by 2 is equal to 7. So what is y? Y is equal now to 7. So if you solve those two equations with the method of addition, you will end up with the value of x and the value of y. So x and y is equal to 2 and 7. Okay, very good. Can you actually implement this method, the method of addition, in the scenario that I started up with? So what did I tell you at the beginning of this lesson? I told you that I purchased 5 mangoes and 5 oranges for $11, and the person in front of me purchased 10 mangoes and 8 oranges for $20. So what is the price of each mango and orange? You should be able now to use the method of addition in order to solve this problem. And I'm going to give you a hint. So the hint here is, imagine the mango and oranges to be the parameters x and y. So 5 mangoes becomes 5x, 5 oranges becomes 5y, and if you add 5x plus 5y is equal to 11. The second equation becomes 10x, which is 10 mangoes, plus 8y, which is 8 oranges, is equal to 20. So now you have two equations and two unknowns. 5x plus 5y is equal to 11, and 10x plus 8y is equal to 20. You should be able to use the method of addition. Somehow try to make one of those numbers or variables a negative sign, and when you add equation 1 to equation 2, you will end up with solving for one variable and use that variable in the second equation to solve for the second variable. And just to give you the answer, I'm not going to solve this example. You can actually do it. It's very easy now to solve it. But the solution for this problem is that the price for each mango is $1.20, and the price of each orange is about $1. So the price of mango and the price of orange is 1.2 and 1. Thank you.